Hi children, welcome to maths class. Today I have come with 6th chapter, the triangle and its properties. We are going to discuss about triangle elaborately. So we begin with its elements which we have studied in the previous grade. What's a triangle? Triangle, you can see, is a closed curve, you can see closed, it's not open, it's closed curve made of 3 line segments. Okay, 3 line segments. Here you can see 1, 2 and 3. It's a closed curve made up of 3 line segments. So the elements of triangles are, it has 3 vertices, that is 1, 2 and 3 angles. Okay, it consists of 3 vertices. Vertices is nothing but plural form of vertex. Okay, vertices, then 3 sides. Here you can see 3 sides, AB, BC and CA or AC. And 3 angles. Angles means angle A, angle B and angle C. Okay, line segment. Sides are written in the form of line segment, named like this: line segment AB, line segment BC, line segment CA. Then angle BAC, ABC and BCA. You can see here angle BAC. Angle A is what? Nothing but BAC. Then angle C, how will you name it? ACB. And the third angle CBA. Angle B can be named as ABC or CBA. Okay, A, B and C. So total 6 elements are there. 6 elements include 3 sides and 3 angles. Angles, on the other hand, they are also considered as vertices. Okay, that is points, corners formed by 2 line segments, 2 arms of them. So A, B, C. Actually 6 elements are there in a triangle. And as you have studied in 6th standard, that based on sides there are 3 types of triangles, and based on angles also there are 3 types of triangles, right? So the types of triangles based on sides are scalene. Scalene is that triangle which doesn't have any same sides, means no 2 sides or 3 sides are same in measure. All the 3 sides are of different measure. Isosceles triangle, this is a triangle which has 2 sides same measure and the third side is having different measure. And equilateral triangle is that triangle which has all the 3 sides equal measure. Okay, all the 3 sides of this triangle has same measure. Now we move on to the types of triangles based on angles: acute angled, obtuse angled and right angled triangle. Acute angled triangle is that triangle which has which has angles less than 90 degree. They are called acute angle triangle. Obtuse angle triangle is that triangle which has at least one angle more than 90 degree, greater than 90 degree. That is called obtuse angle triangle. And right angle triangle is that triangle having one of the 3 angle 90 degree. So this was all about types of triangles which you have already studied in your previous grade. Now children, we can quickly recapitulate what I told you in the previous video, that the types of triangles based on sides, in which you can have an idea in a better way if you see the picture. So look here, you can see the sides PQ, QR and PR or RP. All these three sides are unequal. They are not equal. So this type of triangle is considered as scalene triangle. Then we move on to the next figure, where you have BC equal to AC. Out of the three sides, measure of two sides equal and the third side is different. So what type of triangle it is? It's isosceles triangle. If we talk about the type of the triangle based on sides, then it is isosceles triangle. Now have a look at this triangle. You can see that RS is equal to ST is equal to TR. All the three sides are of equal measure. So this is equilateral triangle. Now we move on to the different triangles based on the angles. Here you can see all the three angles are less than 90 degree. Measure of all the three angles are less than 90 degrees. So it's an acute angle triangle. Here you see one of the angle is 90 degrees. So it's a right angle triangle. And this is a triangle where one of the angle is greater than 90 degrees. So we call it obtuse angled triangle. Today what we are going to talk about is altitudes of a triangle. What is an altitude? An altitude has one endpoint at a vertex of the triangle and the other on the line containing the opposite side. Through each vertex, an altitude can be drawn. Just have a look at this triangle, triangle ABC. A line segment is being drawn passing through the vertex A, and there are several line segments drawn. All are passing from vertex A and intersecting the opposite side of the intersecting the side opposite to that vertex. But in all these 5 cases, you can see this 1, 2, 3 and this is the fourth one. They are actually not forming 90 degree with the side opposite to vertex. Only AL is forming 90 degree. So except AL, the rest of the 4 line segments, they are not considered altitude. Okay? AL is altitude because it is that line or line segment which is passing through the vertex and intersecting the side opposite to the vertex at 90 degree. And so AL is considered to be altitude. And if we talk about the altitude, then line segment AL is considered to be height of the triangle. Altitude, in other words, is considered as height of the triangle, and to which it is forming 90 degree perpendicular. The height or the line segment which is perpendicular to the base or the line segment, that line segment is considered as base. BC here is base and AL is height of the triangle or perpendicular. Similarly, you can get a perpendicular from vertex B also. Then in that case, if I take out a altitude starting from vertex B and say it is intersecting AC at D and is perpendicular, then AC will be base and BD will be height. BD will be altitude and AC will be the base. Similarly, if I draw an altitude from vertex C and I name it as E, intersecting point. Then CE will be the altitude or height of the triangle and AB will be its base. Is that clear about altitude or height of a triangle and the base of a triangle? Now we move on to median of a triangle. Median is again a line segment joining the midpoint of one side to the opposite of the vertex of a triangle from where it is coming out. Here you can see, you will get better idea looking at this picture. Just as altitude, in this case the line segment emerging out from the vertex, passing through the vertex of the triangle and intersecting the side opposite to the vertex, not at 90 degree, but it will be bisecting the side opposite to the vertex. Then it's called median. Is that clear? It's considered as median only when it divides the opposite side, or it divides the side opposite to the vertex. It divides the side opposite to the vertex into two equal parts, BD equal to DC. Then only AD will be considered as median. Did you understand the difference between altitude and median? Both altitude and median emerges out or passes through the vertex and intersects the side opposite to the vertex, but in case of altitude it intersects the side opposite to the vertex perpendicularly, that is, it forms 90 degree. And in case of median, it doesn't intersect perpendicularly, but it bisects the side opposite to it. BC मतलब वो two equal parts में divide कर देता है और BD is equal to DC मिलता है. Then we call that line segment AD as a median of the triangle. Same way, just like altitude, you can have median from vertex B and you can also have median from vertex C. Condition is that the vertex median coming out from vertex B will be bisecting AC. AC को two equal parts में divide करेगा, midpoint को midpoint में जाके मिलेगा, और उसी तरह से the line segment emerging out from vertex C will be intersecting AB in the midpoint somewhere over here. That will be, it will be bisecting AB. So today in this video we have talked about the triangles, types of triangles, and we have talked about two more elements. One is altitude and the other one is median. So children, before we attempt the exercise 6.1 or 6.2, I would like you to watch the video carefully, then read the pages, read the chapter, so that conceptually you get clear and the minute things, in some cases I may have missed it, you can come across. Reading of the lesson is must. So do that. Till then, goodbye.